Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting-edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Christian Sanchez, who has a master's in electrical and computer engineering from the University of Illinois, Urbana, Champaign. How are you doing today?
Good morning, Rohan. I'm doing well. Thanks for the invitation today. Happy to be here.
Yeah. Thank you for joining me. So to get started, I wanted to ask what made you choose your degree for community college?
Yes, thanks for the interview. And I think this is a really great idea, Rohan. Thanks for starting it and getting to interview people so that they can help others in their careers or their decisions to jump on careers. What got me to college? I mean, I came to this country some 19 years ago with the idea of getting high education and in a really good school. And to start off that path, I really wanted something that can help me get there. And a community college really helped on getting my my foot on the door. I went to Truman College, one of the city colleges of Chicago, and had the opportunity to be there, study with scholarship because of my high school performance back in Ecuador, and I started there, right, in a special program. It was called a Transitional Bilingual Learning Community that helped me transition not just on the language side, but also on the academics, right? Learning everything I needed to learn before I could transfer to a four-year university. But the reason I started there and the reason I started my career is because I wanted to get the highest education possible in this country, and that's community college helped me start that.
So when you're in community college, you pick a major then, right? So you did mathematics and what's AS?
I did. Yeah, that's a funny thing because I did want to start with an associate degree in math. I wanted to do different things. I wanted to do physics. I wanted to do math. I wanted to do engineering. I wasn't sure, and at the end, I did choose an associate degree in mathematics because that's what I knew how to do, and I was very good at it. It felt the easiest path for me to do that, and also I was already I was already taking a lot of classes in math, so it makes sense to just do an associate degree in mathematics before transferring to a four-year university. In reality, though, it's something I like to do at the time, and I had a good time in college, and it kind of made it easy on me to take that path of getting an associate degree in math.
Yeah. And then I see you did your bachelor's degree in 2 years, so I'm sure you knocked out like a bunch of your classes doing that associates, right?
Yeah, well, in reality, I did take a lot of classes. I think it spent roughly 3 years in community college because I had to start at a lower level for some classes. Even math, I had to start over from the basics because of the language difference, not the academics part of it, but the language. I had to relearn everything I knew already in English. So for me, it was a little different, but that's what, if you don't consider those like beginning classes, yeah, it was roughly 2 years in just taking the actual classes that will help me transfer to four-year university. Otherwise, I think it was roughly 3 years.
Yeah. So what made you pick electrical and computer engineering?
So ever since I was like a young person, when I was still in elementary school, I wanted to be an engineer. Like that's all I wanted. I knew I wanted to be an engineer. I think my parents put that mindset in me to do that, to become an engineer. What kind of engineer? That's something we never discussed. That's something that never really was brought up. And even until I got to Champaign, I didn't know what to do, right? What type of engineering? But only I knew that I wanted to do engineering. And before transferring, of course, I had to see what college do I go to, and I just selected something that was close to me that I knew at the time, which is electrical and computing engineering. But I didn't know exactly what to specialize in. Within electrical engineering, there's a lot of different specializations, right? You focus on something, whether that's power electronics, telecommunications, power, energy, things like that. There's a lot of different branches that you can do within electrical engineering, even at school. But in general, I just wanted to be an engineer. What type of engineer, that was still uncertain before I selected my actual path.
Yeah. Oh, what was your experience like while getting your degree?
That part was hard. Transferring from community college to a four-year university, specifically to the University of Illinois at Urbana, Champaign, it was kind of day and night type of transfer. Being a transfer student means that you're no longer going to take general education classes, the gen eds. Most of that is already done in the community college. Some also advanced classes in math or English is also kind of done. So you only take classes on the major that you're going to specialize in, right? Like 3 4 engineering classes. Even the electives sometimes are engineering classes. So my workload was very heavy. I was taking 3 4 classes, engineering classes every semester, and the difficulty, the level of difficulty of the college itself, it was different, right? It was higher. You're competing with other students who are bright, just like you are, and that made it very very difficult. Like I had to, even though I was a very good student, I was always getting A's and B's. In Champaign, I had to like bring it up a lot, right? I have to really be dedicated, be responsible significantly more because of the level of education that the college provides, and maintain that because it has to be sustainable. I had to be there for at least 2 more years, so at least 4 6 more semesters if I take summer classes, and dedicate my time to do that. And you need to be very disciplined, very focused, but it was challenging. Yeah, the classes were harder. The students were also very bright, very good, very responsible, dedicated people coming also from backgrounds that they were good at, right, before. So yeah, it was challenging to say the least.
Yeah. So, what made you want to get a master's then?
The master's degree. So once I finished my bachelor's degree in electrical computer engineering, I so before I actually finished that, there was a time where I got a scholarship from ComEd, from the electrical utility, and the people who gave me the scholarship told me that I should be focusing on, or should be specializing in, power energy systems. I'm in a good school, one of the best in the public schools in the country for power, and I should probably do that. And I took their advice. Because I was in between telecom and also power, but they made me select, like, okay, I'm gonna focus on power, and I think that happened like right after the first semester before going to the second semester. So I specialized in power and energy systems, and I knew the professors very well. I got very close to one of them, and my advisor, Peter Sauer, he actually recommended me. Like when I told him, "Hey, I want to do a master's degree. I know it's very competitive here," and he told me, like, if you really want to do it, I mean, you can. He will support me, right, in doing that. And in for grad schools, what you really need to do is try to convince some of the professors that you can work so that you can work with them. They have a limited amount of people that they take every year for their class because they work for say 9, 10 students, research students or TA students for their cohort. And he opened up a position for me to do that, and I still had to apply, of course, and compete through uh, the application process and the selection process. But the professor already knew me. I've been working with him for a long time in my bachelor's, and that's what made me really make the decision to jump on grad school. He convinced me, like, let's do it. Like, you're a good student. I'll take you in. You can continue here. You don't have to stop, and we would be continue to do what we've been doing, but at a grad school level in power energy system. He gave me the opportunity. I took it. And then of course I realized he and the program is one of the best in the country. So that kind of solidified my decisions to stay there, even though it was very hard. The master's degree was even harder than the bachelor's. I had to work on my thesis. I had to be a research assistant to my professor, for the thesis, for students, and that part was I think I struggled a lot. I wasn't expecting something like that, but yes, I that's the reason. The encouragement from my advisor, the being one of the top schools for engineering for power, and being there already, having that opportunity to continue to do that right after my bachelor's. It's the reason I did it.
Yeah. Would you say a master's is very helpful in electrical engineering, or does it really depend on what you're going into?
So for people who want to take a master's degree, so first of all, my master's degree, I had a tuition waiver. I was a research assistant. They gave me even a stipend per month to cover expenses. So it was a very um, supportive environment, financially speaking. Now, I did not know exactly what to specialize in my master's degree. I just knew I liked power and energy, right? And I enjoy the classes, but like I said, it was very challenging to go through it. For people who want to decide, like, should I do my master? Is it going to be um, valuable, right? Once I jump in the industry, in my in my experience, yes, it was valuable from a salary perspective. Compared to my peers, I think maybe there is even today, maybe there may be a 10K difference in salary if you have a master's degree, depending on where you go. In general, though, what I recommend today for people to do is, if you cannot, for example, afford it financially yet, or if you're not sure what you're going to focus on, to wait maybe a year or two after you start working in your discipline, in your career, in your field. Wait a year or two before deciding to go back and getting a master, because then you will know exactly what you want to learn. Then you know exactly the challenges that you're facing in your job, and maybe you can research about that during your master's degree. And on top of that, maybe your employer may be able to pay for it. Um, if they have tuition assistantship, for example, tuition reimbursement benefits in the company, it's something that they should be able to leverage. So you'll have two things going for you. One, you know exactly what you want to do and why. Why I want to do the master. You will know then. And second, it will potentially be covered significantly. A significant portion of it will be covered. Now, if you have the opportunity, like I did, to join that grad school program right after a bachelor's degree with a tuition waiver, I mean, no brainer, right? Go for it, because it is valuable. The reason I say for some of them to wait is if they don't have that opportunity, or if they don't know exactly why they need to do it or what they're going to study, maybe then yes, wait a little bit. But it is valuable in the field for sure.
What was your first job out of your master's?
My first job was a consulting opportunity with a company in downtown Chicago. It's called Sargent Lundy. It's a very renowned engineering company, and so that's after I finished school, my first job, and I think I stumbled on renewables, but a little bit by luck. I was supposed to start with them in the nuclear division as an electrical engineer, electrical associate engineer in the nuclear department. The day before I started with them, they called me and they told me, hey, we need more support on in the what was called the Power Delivery Services group, which is a group that focuses on grid infrastructure, substation, power substations, transmission lines, and at the time they were also doing and needed support for wind power plants. So right after I started, I worked on interconnection, um, support for generators, any generators. Some of them were solar generators, some of them were wind, some of them were conventional generators. And then I started working in actual wind power plants, beyond just the substation and grid infrastructure. I think, again, by luck, I ended up in that position, which is something I really wanted to do, work in renewables. And and um, and then Sergeant Lundy gave me that opportunity to work on wind power plants right after I finished my school, and I did that for 4 years. So I really I learned the fundamentals of project engineering, electrical engineering for renewables right there with them. But it was luck, yes, but I was prepared for it, right? That I think that's what makes the difference. When you strike luck, you better be prepared to take that opportunity, to take that luck, and then that kind of started my career
Yeah. So can you talk a little more specifically about what you worked on there?
in that job.
Yeah.
Specifically, so I was doing designs for substation and switching stations. These are the power stations that take the power from generators and then send it to the transmission system, which then is distributed to your home. This is the bulk electric power system, right? The backbone of the power in the country. So I was doing some of that design on the protection and controls, physical design. I was also doing studies like grounding studies, using most or everything that I learned back in school. Of course, we use tools for that, software that is already specialized, and engineering software and tools specialized for the use for what we're doing. So grounding studies, power flows, ampacity studies for substation, but I'm also doing the design for collector systems for wind power plants. So understanding the wind turbine generators, how they provide power, how they generate the power and reactive power for the grid, understanding sizes of cables, voltage drop, how to route cables, and do the detailed drawings for trenching from the turbines all the way to the collector substation, for example, the transition between that. I was doing all of that. And at the time at Sergeant Lundy, I became one of the youngest persons to own the process to do this, the process to design, the process to do the studies for wind. So it was a very rewarding experience.
Yeah. So what was your next job?
After that, I wanted to start doing solar. At the time, wind was already in. I think I joined when wind was at its peak, but starting to kind of decay a little bit. But solar was starting to kind of ramp up, and I joined another company called SNC Electric, which is based here in Chicago as well, close to Evanston. And I joined that company to start doing more solar projects, solar and battery projects, small solar and battery projects, anything from one megawatt to maybe 5 megawatts level. And for when I was in Sergeant Lundy working on wind power plants, it was anything from 80 megawatts to 300 megawatts, huge power plants, right? Here at SNC, it was a smaller, but it was solar. It was a new technology for me. And I was doing project engineering for some solar projects and battery projects. And I was also learning about distribution systems. So the automation of the distribution feeders, the part of the grid that brings power to everybody's homes. So distribution feeders are the backbone for, like at the residential, commercial level and industrial level. It brings the powers to everybody's home, everybody's building, campus, etc. So I was learning how to automate that, make the distribution system more resilient, more reliable with automation, automated equipment that SNC made and continues to make until today. But I learned more about solar, how to design solar power plants, battery power plants, how to couple them, create all the drawings, specification for equipment, a scope for what we're going to do as what we call them EPC, the engineering, procurement, and construction team. And I was doing the engineering for them and working with construction crews, the procurement team to buy equipment, to build these projects, support any questions the team may have, changes that they may need to do on site, things like that. But I was the person responsible, the project engineer responsible for the design of solar PV power plants.
And then when you're designing a solar power plant versus a wind-powered power plant, is the work very different?
There are similarities. I mean, in solar, solar has, as you know, large footprint because of large modules. You need a lot of them. The quantity is larger. The land requires larger than like a wind turbine, for example. We have a DC, like direct current side of things, because when the solar panels convert sunlight to electricity, it's in DC, in direct current terms, and that needs to be converted from DC to AC, which is what we use in our grid, AC power. In wind, it's all AC power, so we don't need to worry much about the DC side. We have an actual generator on the turbines. Everything from the AC side is very similar. We still collect power on medium voltage cables and bring it to a substation. That part is very similar. The part that is different is the resource itself, the DC side, the array, the solar array, the land that we're gonna need for the solar array, the panels, versus the locations that we need for turbines. Turbines, because they're also very massive towers, and because of the resource of the wind, they need to be spread out through even larger, miles away from each other. But the space they take per tower is very minimal compared to a solar power plant. In solar, you need all of them concentrated into one location, but so you need a lot of acres, a lot of land. So a lot of impacts to wetlands, a lot of impacts to maybe talking to neighbors for noise, for visual impacts, glare, for example. And for wind, it's a little different. For wind turbines, it's a little different. It's the noise from the blades, flickering from the shadows of that wind of the turbine. The analysis is a little different on how much energy is going to produce, because one relies on wind blowing, the speed of the wind, versus the other intensity of the sun, right? And which varies through the year, through the seasons, same as wind. And so the resource and the analysis is a little different on how much production there will be, but the intricacies of the actual getting from the generator to the grid, to the substation, and to the grid is very similar. We still have to do power flows for studies for both, reactive power studies for both. We need to do ampacity calculations to size cables on both. We still need a substation. We need harmonics studies done, similar studies and similar design on the AC side of the power plant. Very, very similar. Yeah.
So what was your next job?
So after that, After SNC Electric, I wanted to do, because I mentioned it was 1 megawatt to 5 megawatt level of what we call distributed generation, smaller size power plants. I wanted to do big ones, the utility scale, like we call it utility scale power plants. And these are the 80, 100 megawatts, the mega projects. So I wanted to do that, and I became a consultant again. I went back with Sargent Lundy in the consulting arm of the firm. And as a consultant, I help developers, utilities, other stakeholders in renewables for the trifecta: wind power plants, solar power plants, and also batteries. Batteries were becoming more and more at the time. They were becoming more of a trend in the industry. There was a lot of startups that were working exclusively on batteries. So I was supporting a lot of these startup developers that now are well positioned in the industry, but at the time they were barely starting and needed somebody who understood the power flows from a battery into the grid. Somebody who understands the interconnection, the substation, how the substation connects the batteries to the substation, and then substation to the power grid, how that the whole system works, right? Utilities were still very cautious about, they still are cautious about batteries, so they needed somebody to help them understand them from an owner's engineer's perspective. There were banks who needed an independent engineer to check the power plants that they were gonna finance. So they needed an independent engineer, to look at the studies, the design, the risks associated with some of these transactions, so to understand the risk and then the probability of some of these risks actually becoming a reality, mitigations, things like that, because they were going to finance those projects. So I became a consultant for a number of different actors in the grid, different big name developers in the industry and utilities as well. And I did that for some time back with Sargent Lundy.
So I saw that you got an MBA. What was your motivation for that?
Yes, that happened during my time at SNC Electric. I decided I should go back and get an MBA because I wanted to understand the management side of what we do, the business side of what we do, from a corporation or business perspective, but also from a management, like a team's perspective, how to manage teams, how to manage people, how to manage projects, how to manage a company. And in the process, I realized, and that was the time, maybe right before COVID, they were doing a lot of virtual MBAs, like online MBAs, and I took the opportunity to do that so I could continue to work and do an MBA at the same time. Versus, I think there are nighttime programs as well, nighttime MBAs. But this one aligned very closely to what I needed at the time. And it helped me understand all of these things, right? Like the commercial side, the business side of everything. And in the process, I learned about strategic management, strategy for a company, for yourself, how to brand yourself. And I also understood about the financing side of projects, capital projects, mega projects. So that helped me connect it back to what I was doing in on the electricals and the technical side. I understood power flows, and then I needed to understand the cash flows, the why or the how these renewable energy power plants, make money. How do we bring cash into the equation? So there is a really good connection between, power plants being designed, engineered to precision, engineering well, in order to sell energy, and then understanding the financial impacts, the financial models to see what cash flows we're going to receive because of that well-engineered power plant. So those two things fusion, and we talk about that on a daily basis now in the industry, about the power flows from a power plant, and the cash flows that then benefits the company, the stakeholders in that project. So it was really a moment where I realized those two things are very much linked, and that's that's the reason. Well, it started with a different reason, but at the end, I learned about that right through the MBA program. If I had to do it again, my MBA was a general MBA, the traditional MBA people go back to school for. If I had to do it again, I would do an MBA in energy, like a focus in energy. And there are those programs today. At the time, they were starting to show up. Now they're well-established MBA in energy programs throughout the different top schools.
Yeah. So for my last question, I wanted to ask what advice you would give someone who's still in high school or early in college wanting to go down a similar career path as you.
Sure. Yeah, high school is very early, but I think people do start thinking about this. Some people start thinking about this very early in their life, and that's great. My advice is to find what you like to do, right? Find your passion. And I know this may sound like cliches to some of you, but it is real. It's very true, and it will help you sustain your progress throughout time. Find what you like to do the most. You need to see and observe. You need to maybe do things hands-on to understand your, like, if does this really motivate you. You need to be self-motivated as you go through your career, and to do that you need to be passionate about what you do. I love what I do, right? I've been working in renewables for 12 years, and I know my North Star. I know we need to decrease the impacts of climate change, not just for us, but future generations, right? My kids and the kids of my kids. We need to protect them, do everything we can today to decrease the impacts, the environmental impacts to them. We know it's real, and that's my North Star, reduce the impacts of climate change. And that's why I do what I do. So finding something that is meaningful to you and learning about that, doing something that is going to relate to that or help you achieve that. Finding that passion, finding that North Star will help you go through your career, will help you make decisions later in your career, versus having, other type of posts in your life or references in your life. I think that's maybe the main thing that you need to focus on the passion, like what excites, and go work or go to and do that. And maybe in the beginning, the initial steps, it could be something simple like, oh, I like math, I like chemistry, or I like biology. Do that, right? If you like it, do that. Follow your heart on that end. And then the second thing that I'll recommend is, once you find your passion, once you find what you like to do and like to learn and would like to have a whole career and whole life around it, make sure you get good at it, right? Learn everything you can about it. Be so good that people cannot ignore you. There's a book about that. Understand getting the skills that you need to later apply it in your job. Like I mentioned before, I was lucky to get into renewables, yes, but I was prepared, right? I had a whole background on it. I knew exactly what I needed to do. I had the fundamentals in place, and I still do. My fundamentals will always be engineering, right? Energy, power flows. That's my fundamentals, and I work on that, and I like it. I have my North Star. I use my skill sets to achieve or to get to my North Star. I will take people very, very far in life, not just in their careers, but in their personal lives as well. I mean, it's a very, from my perspective, a reasonable advice for people in high school, people in college, before they select their majors, before they select their classes, even to think about those two main things that I recommend.
Yeah. All right then. Thank you for meeting with me.